Lesson 1.5 focuses on solving inequalities. We have two objectives listed, but we're going to just focus on the first one, solving and graphing inequalities. Alright, on the next slide, we just have some basic examples. So the word sentence x is greater than 4. Alright, how would you write that as an inequality? That's right here. And then the graph. Alright, notice that greater than and less than. So notice those. They have open dots. Okay, so when we're dealing with greater than or less than, we have an open dot on the boundary point. In all four of these inequalities, 4 is a boundary point. Alright, now we look at x is greater than or equal to 4 and x is less than or equal to 4. Notice for those, the boundary point 4 has a closed dot on it. So greater than or equal to or less than or equal to means a closed dot. Now I also want you to add the last part that I added here, because this can be confusing when you're solving these. Whenever you see the words is at least, that would indicate greater than or equal to. And whenever you see at most, is at most, that would indicate the inequality sign less than or equal to. So keep that in mind moving forward. In problem 1, we're going to write an inequality from a sentence. And that sentence is 5 fewer than a number is at least 12. Alright, so let's go through this. Fewer, what keyword, what operation would that indicate? And that would be subtraction. So we have 5, and then fewer would indicate subtraction. Then a number. Alright, so we can represent that as n. And then is at least. So is at least indicates greater than or equal to. And then 12. Alright, now whenever we're dealing with subtraction, we have to really pay attention to the order. So 5 fewer than a number would indicate I have to flip this around and write n minus 5. So this right here is 5 fewer than a number. And then I can go ahead and finish it by writing is greater than or equal to 12. And this is an inequality that represents that sentence. Okay, now solving an inequality is like solving an equation. You isolate the variable by doing the same things to each side of the inequality. Remember, however, when you multiply or divide each side of an inequality by a negative, you need to flip the inequality symbol. So in problem 12, we need to figure out what the solution of this inequality is and then graph it. Alright, so we're going to treat the inequality sign like an equal sign. Or just as if it was an equal sign. Alright, the only difference is if we multiply or divide both sides of this inequality by a negative, you need to flip it. Alright, so the first step is to, remember our steps for solving equations. The first thing you want to look for is, can you simplify or combine like terms on the left or right hand side of the inequality. And in this case, we can simplify this, and we're going to do it by distributing the negative 3 to the 2x and the negative 5. So negative 3 times 2x is going to give us a negative 6x. A negative 3 times a negative 5 is going to give us a positive 15. And then we're going to add 1, and that has to be greater than or equal to 4. Alright, now we can combine like terms. We have a positive 15 and a positive 1, and that's going to become 16. So we have negative 6x plus 16. That's greater than or equal to 4. Okay, so we've simplified and we've combined like terms. The next step is to look, is there variables on both sides of the inequality? And the answer is no. So we go to the next step, which is to isolate the variable. So we want to get x all by itself. Now, in order to do that, we're going to subtract 16 from both sides first. So I'm left with negative 6x. I bring this down. The positive 16 and the negative 16 become 0, so that goes away. And then I write greater than or equal to. Notice I did not flip the sign because I just subtracted from both sides. Okay, I only flip when you multiply or divide both sides by a negative. So now we have 4 minus 16. That's going to give us a negative 12. Alright, so now we have a negative 6 times x. We want to get that x by itself. What undoes multiplication? Division. So we're going to divide both sides by negative 6. So negative 6 divided by negative 6 is a positive 1. So I'm just left with 1x, or x. I flip the inequality sign because I divided by a negative. And then I have negative 12 divided by negative 6. That's going to give me a positive 2. So all numbers less than or equal to 2 will satisfy the inequality above. And we're going to represent that with a graph. Alright, we'll put positive 2 here, positive 3, positive 4. So we got a couple numbers to the left and to the right of our boundary point, which is 2. Now this is less than or equal to, so that would indicate a closed circle on the boundary point 2. And our x's have to be less than that, less than or equal to that. So I'm going to shade to the right there. So here's my solution, written as an inequality, and that's how it's represented by graphing. Okay, the last example we have, what's the solution of the inequality? And again, graph the solutions. So, treat the inequality like an equation. How would you solve an equation? Well, you'd first begin by seeing, hey, can I simplify anything on the left-hand or right-hand side of the inequality sign? And the answer to that question is yes. I can simplify the left-hand side, and I'm going to do that by distributing the negative 2. So negative 2 times x is a negative 2x. Negative 2 times a positive 9 gives me a negative 18. And then I add 5, and that has to be greater than or equal to 3. Alright, combine like terms. So a negative 18 and a positive 5, that's going to give us a negative 13. Alright, so step 1 is finished. Step 2, is there a variable on both sides of the inequality? And the answer is no. So I can proceed to the third step, which is to isolate the variable x. Alright, now I'm going to add 13 to both sides. Alright, so I'm going to get negative 2x So negative 13 and a positive 13 cancel. And I think it's worth noting, notice that I added 13 to both sides first. Don't divide. You want to do your addition and subtraction. You do those inverse operations before you do the multiplication and division to make your life a lot easier. All right. So I'm going to be greater than or equal to 3 plus 13, which is going to be 16. Okay, now we can go ahead and we have negative 2x, negative 2 times x. So what undoes multiplication? Division. So now I can go ahead and divide by negative 2, both sides. Since I divided by a negative 2, I'm going to flip the inequality sign. 16 divided by negative 2 is a negative 8. So all numbers less than negative 8, less than or equal to negative 8, are solutions to this inequality, and we can represent that on this graph. So negative 8 is my boundary point, so I'm going to put that right in the middle. What are some points greater than negative 8? Negative 7 and negative 6. And some points less than negative 8, negative 9 and negative 10. On negative 8, I do a closed circle because it's less than or equal to. And then I'm going to shade to the left. Alright, so there's my solution as a graph, and here's my solution written as an inequality.